Today we're looking at a divisibility test for a 5-digit number with a missing digit D. And sometimes you see this horizontal line to indicate this does represent a 5-digit number where D is unknown. Now again, this is Hindu Arabic, it's base 10. So we're assuming that D is a positive integer. Sometimes you see it written like this, Z plus. And maybe a non-negative integer would be a better way to say this, but D could be between 0, 1, or it could be take on these values 0, 1, 2, all the way up to 9, because this is base 10, right? So D can take on these values, and again, this should be just non-negative integers, I guess. Okay, now here's a divisibility test that's a little more obscure than the ones you're used to seeing. 2, 5, 10, 9, 3, even 7, 11 have divisibility tests. This one's not quite as common. Let's look at a concrete example here. Say if we wanted to know if 2002 was divisible by 13. Okay, so we're asking a question, is 2002 divisible by 13? Now, of course, you could do long division or cheat and plug it into your calculator, but what if you wanted to do it theoretically, all right? Now, this little algorithm here says, I'll just write down what it implies, okay? You're going to remove the 2, but you're going to add 4 times to 200, right? So in other words, this implies 208. Right, folks? Because again, 4 times 2 is 8. You remove the 2 and then you add it to the 200 to get 208. But notice that this is equal to 16 times 13. So you get a 3-digit number that's a little easier to do by inspection. 16 times 13 is 208 because it's equal to 160 plus 48, which is 208. Okay, so we know that 202 is divisible. You can put if and only if arrows if you want to here. And by the way, folks, I have the proof of this. You guys can check this out if you want to. This works primarily because 40 is congruent to 1 mod 13. You can check this out. I did this in a video not too long ago. Our test for divisibility by 13. And it's an interesting little proof. I like that more than just the computational stuff. But this problem here is a little bit of a challenge itself. Okay, so let's move along. And so again, I'm just going to apply the algorithm. You can see right here, this is, we drop the 7, right? But we add 4 times the last digit to this object, right? And so you see this is tantamount to just the good old grade school addition problem of if you have 1D, where again, D is a digit between 0 and 9, and you want to add it, you want to do addition here. You got 28 right here, and you can see how this is going to work out, right? It's the same kind of standard stuff. 8 plus 4 is 2. That's where this 2 comes from, right? But you have to carry and carry, and you have to carry all the way over to the D digit. So that's this process leads to this statement right here, okay? But it's still not clear. You have these 2 digits at the end, right? This is the digit 1. This is the digit 2. This isn't 12 times this. This is a 4-digit number, the first digit, the second digit, the third digit, the fourth digit, right? So we still have no way of knowing at this point. So there's nothing that says we can't repeat this algorithm, and that's what we're going to do on the very next line. Okay, again, the very, very same thing. We dropped the 2, right? We dropped this 2, but we had to multiply it by 4, which is what happened right here. You see this 2? This 2, the same thing, right? But we dropped it, okay, and when we add it, we get this, and again, in a similar fashion, it's an addition problem. This is perhaps a little bit easier to see. Now we're at a point where applying the algorithm is not going to do any good because we would just have to multiply this by 4 and add it. You know, I mean, it wouldn't. It's that you're not going to get anywhere with that algorithm if you try this. Okay, and so what you can do is just realize that the form. It's a 3-digit number. Again, this is a 3-digit number, okay? And so it begins with 1, and I've listed the multiples of 3. Notice this is what, the multiples of 13, excuse me, 8 times 13. This is 8 times 13, right? And it satisfies the requirement that 1 is in the beginning position. And so it's real easy to write these down. You just keep adding 13, right? You keep adding 13. And we are looking for a 9 in the last position, right? Well, that only happens one time. So it's kind of nice, isn't it, folks? Kind of slick. All right, and so what we can glean from this is that D plus 1 must equal to 6, right? The 6 you see right here matches up with the D plus 1 digit right here. Again, 3-digit number compared to this 3-digit number. Notice this is the only one that ends in 9. Look, you got 7, 0, 3. 13 has a period of 12, I believe. You can, that's just has to do with the tau function, actually, if you want to, or excuse me, the phi function, I believe. But in any event, there's only one of these things that end with a 9. It's this one right here, 169. And so this implies that D equals 5. So that's the answer. And notice we still don't know what the product is. I mean, we just know that this is a test that proves divisibility. It doesn't prove what the actual product would be. Okay, so let's come back up here, folks. D is equal to 5. And again, that's a tough calculation, isn't it? If you don't, especially with the D being in this position, a priori you wouldn't know what digit this really was. Divisible by 13 is a little bit more of a pain than the others. You know, the larger the number gets, I guess in a manner of speaking, the harder the test gets. But anyway, that is the answer. And again, if you want to know more about where this rule comes from, I did this a while back, and you can go back and look at the video. The video, I like the proof better. Like I said earlier, the proof is very intriguing to me. The way you write down your number and then you write down the remaining number with this algorithm applied, right? And then if you process this, you end up with 40 congruent to 1. That's what makes the thing tick. And you can see that it's an if and only if, just everything's reversible. But okay, so that's that. And then this is the answer to the question, folks. The digit is 5. So in other words, what does that mean? That means that 13 divides 1, 5, 8, 4, 7. I have no idea what it is. It would have to be a 3-digit number, though, right? You'd have to, some 3-digit number, I think, or maybe a 4-digit number even, I'm not sure. But anyway, we do know conclusively that 13 divides this value right here. Okay.